Hi, good to see you again. Welcome to Block 5, Addition and Subtraction of Fractions, Lesson 11. I'll share my screen. So, in your previous lesson, you learned how to work with fractions in algebraic context. In today's lesson, you're going to learn how to use your knowledge of equivalence to add and subtract decimals and fractions. It's a very useful skill that you would find incredibly important in your journey of learning maths. But remember to like the video, subscribe to the channel, share the video with those you think can benefit, and click on the notification bell so that when new videos are released, you will be notified. By doing so, you help us grow our mission of providing a platform where anyone who is struggling with maths or any child who doesn't have access to private tuition can just use internet access to still learn and have good achievements in their study of maths. Before we start, I would like you to pause the video and answer the retrieval practice questions in 3 minutes. Assuming you've paused the video and you've answered the retrieval practice questions, here are the answers. Let's discuss them. So for the first one, you simply ask to convert the fractions to decimals. Now, you should know some of these fractions, they are equivalent decimals. Okay, so for this one, we know 1/5 is 0.2, so 2/5 has to be double of 0.2, which is 0.4. 7/10 we know is 0.7, and 1300ths as a decimal is 0.13. Next, you're asked to convert the decimals to fractions and then simplify your answers where possible. By now, you should know by equivalence that 0.75 is equivalent to 3/4. So we write that. We know that 0.6 is 6/10. Now, when you simplify 6/10, which is 6 over 10, you can divide the numerator and the denominator by 2. That will give you 3/5. 0.14 can be written as 14 over 100, which when you simplify it by dividing by 2, you will get 7 over 50. 0.17 can be written as 1700ths. Let's do some new learning for this lesson. Look at the number lines. What's the same and what's different? I want you to have a think. Well, I'm sure you've noted that what's different is that although the number lines, they have the same width apart, you can see that one is 0 to 1 and the other one is 0 to 0.1. So it means the values of each of the intervals or the markers on the number line won't be the same. So this one will be 10th, while this will be 100th. Okay? Now, using what we know so far, we can start to do some interesting things. For example, if I ask you, what is the value of the position of the arrow? Well, we already know that each of these interval is 1/10 because from 0 to 1, we have 10 intervals. So if we divide 1, okay, because the difference between 1 and 0 is 1, if we divide 1 by that 10 intervals, it means each of these is increasing by 1/10. So this has to be 2/10, which is 0.2. This one, we know that we have 0 to 0.1. So if we use our knowledge of what we know, this one will be 200th, which will be 0.02. I'm just going to pause to just address something really quickly. Just a minute. Okay, thank you for your patience. So I'll share my screen again. So as I was saying, so this will be 200th. Okay. Why? We know that 0.1 minus 0 is 0.1. So the difference between the start and the end of this number line is 0.1. Now we have 10 intervals. So if we divide 0.1 by 10, it's going to be 0.01, which is 100th. So this has to be 200th. Okay, let's now start to use our knowledge of equivalence to start to work with problems like this. So if we are asked to work out the calculation 3/10 plus 0.7, we can do it in different ways. First, we can say, well, we know that 3/10 is 0.3. So if we convert it into a decimal, we can simply just add 3/10 to 0.7, which is 0.3, plus 0.7, which will be 1. We can also do it like this. So we can convert 0.7 to 7/10. So you can see how our knowledge of equivalence is becoming useful. And then because the denominators are the same, are equivalent, we can simply just add the numerators, which is 10 over 10, which is 1. We could also use a number line to do this. So we know that 3/10 is in that position and we want to add 0.7. Of course, we know each of these interval in this number line is 0.1. So we simply need to do 7 jumps or 7 steps, which will be 1. Okay. Now, what about this one? If we're asked to work out the calculation, but now we are restricted, we're asked to give our answer as a fraction, we could do it in different ways. So first, we could convert 0.7 as 300th to 0.03. So first, we do it as a decimal if you find that easier. And then when you finish, you convert that to a fraction because that's what you were asked to do. So you convert this to a fraction, which will be 6700th. Another approach is this one here. So you can convert this to a fraction, which is 7/10. Now, you know 7/10 is the same thing as 70/100. And then you can do your subtraction because the denominators are equivalent, which will give you the same answer. You could also use a number line to do it. So we're using between 0.6 and 0.7 because we know that we want to subtract 100th from there. So dividing, we know the difference between them is 0.1. Dividing these 10 intervals, dividing 0.1 by these 10 intervals means each of these is 0.01. So that way we can subtract 0.03 from it, which is 300th. So if we want to subtract 300, it means we're going to count 3 steps because that's 0.1, 0.01, 0.02, and 0.03, which will take us there. And of course, our answer is 0.67. Okay, what about this one? If we're asked to do a calculation like this, we can use our knowledge of equivalence to do it. So the calculation may look a bit strange at first when you see calculations like this, 0.75 minus 1/6. But using your knowledge of equivalence, it becomes really easy. So you know that 0.75 is 3/4. So when you use your knowledge to say, oh, okay, I can actually do this because they share a common multiple, then you can change the denominator to the common multiple of 12. Of course, to do that, you're going to have to multiply by 3, which you must do to the numerator as well. And to change 6 to 12, you have to multiply by 2, which you must do with the numerator as well. So now you have this. And of course, you can do the calculation because you can simply just subtract the numerator because the denominators are equivalent. So you can just say 7/12. It's now time for you to apply what you've learned by practicing some questions. So pause the video and answer questions 1 and 2 in 3 minutes. Assuming you've paused the video and you've answered questions 1 and 2, here are the answers. Let's discuss them. So for question 1, you were asked to fill in the boxes on the number line. Note that you have between 0 and 1, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 intervals. Now, if you divide 1 by 10, it means each of these interval is 0.1. So that should be 0.1, 0.2, 0.3. So that should be 3 tenths. This should be 5 tenths, 7 tenths, and 0.8. So these are simple equivalents that you should know. Next, you were asked to work out the calculations, give your answers as decimals. You could use the number line to help you. So this is like saying 0.3 plus 0.5, which is 0.8. This is like saying 1 minus 0.8, which is 0.2. This is like saying 0.7 add 0.3, which is 1. Here, question 2a, you were asked to fill in the boxes on the number lines. Now you can see that this is hundredth. Okay, so this is similar to the number line that we've seen when we looked at our first examples. So here it should be 300th, 500th, 700th, 0.08. And then you're asked to work out the calculations giving your answer as decimals. By now, you should know that that's 0.03. So your answer should be 0.08. And then this is 0.1 minus 0.02. Okay, which I think that is what it is. I'm sure I'm saying the right thing. Let me move this out of the way. Sorry. So that would be 0.1 minus 0.08 because that's 800th. So that should give you 0.02 as your answer. So I was right. Okay. Next, you're asked to pause the video and answer question 3 in 3 minutes. Assuming you've paused the video and you've answered question 3, here are the answers. Let's discuss them. So here you were asked, just a minute, let's move this out of the way. So here you were asked, here are some bar models drawn above number lines. You were asked to write each decimal as a fraction. Okay, you could use the bar models to help you. So the bar models are just there to help you. So if we're going to write the decimals as a fraction, that's a 1/2, and that is a quarter, and that is 1/5. Now, this method is useful because sometimes when you're dealing with certain number lines that you're not sure of, you can actually visualize overlaying a bar model on the number lines. It's a very helpful way to answer questions like that or to solve problems like that. And then next, you were asked to use the number lines and your answers to part A to work out the calculations. So here, we know 0.1 plus 0.5 because half is 0.5 should be 0.6. We know 1/5, which is 0.2 plus 0.5 should be 0.7. We know 0.90 minus 0.25 because we know a quarter is 0.25 should be 0.65. Okay, so if you do not know how to do this calculation, you can refer to our lessons where we have learned how to do calculations like that. Okay, pause the video and answer question 4 in just a minute. Pause the video and answer question 4 in 2 minutes. Assuming you've paused the video and you've answered question 4, here are the answers. Let's discuss them. So question 4, you were asked to work out 0.3 plus 3/5. Now, here is where equivalence becomes very useful. If you remember from our very early lessons, we know that a fifth, 1/5 is 0.2. So we know that 1/5 is 0.2. So 3/5 will be 3 lots of that. So 3/5 will be 3 lots of 0.2, which is 0.6. So here they're asking us to add 0.6, yeah, to 0.3. So it should be 0.9. We can use equivalence to answer this question, can't we? Of course we can. We know that 0.75, at first when you look at a calculation like this, you would think that is so challenging, but it really isn't. So 0.75 we know is equal to 3/4. So you know these equivalents. So now this becomes something as simple as this. Okay, now you need to make the denominators equivalent. So you need to multiply that. The common multiple of 6 and 4 is 12. The lowest common multiple of 6 and 4 is 12. So we'll multiply that by 2. We need to do the same to the numerator. We multiply this by 3. And we need to do the same to the numerator. So your calculation now becomes 212 plus 912. Okay? The denominators are equivalent, so you can simply add the numerators. So your answer will be 1112 because 2 plus 9 is 11. Okay, let's move on to the second part of our lesson. What if we have questions like this that may look a bit really challenging? Do you think they are challenging? Well, we can do it in different ways. So we have 7/20 minus 0.1. Well, we can first think about making 7/20 to have a denominator of 100. Why? Because we know that 0.1 is 1/10 or 10 hundredths. Okay? So we're using that knowledge to solve this problem that may look challenging. Yeah. And of course, we know if we do that, it's going to be 3,500. Why? To change 7/20 such that it has a denominator of 100, we need to multiply 20 by 5, and we need to do the same to the numerator. So 7 times 5 is 35, and then 20 times 5 is 100. Now, when we do that, that will give us 0.35. So our calculation actually becomes 0.35 minus 0.1. Of course, I'm sure you know how to do decimal subtraction. If not, go and refer to our earlier lessons where we've done something like this, where we've learned a concept like this. So now your answer just becomes 0. Okay. Do you think it's 0.34? Have you think? Of course not. It's 0.25. Yeah. What about this? You could also do it like this. You could say, okay, because we need to make our answer a decimal, some people may say, I want to use the approach of using the fraction. So you know that 0.1 is 1/10. So your calculation actually now becomes this. So 7/20 minus 1/10. Now, do you notice that they share a common multiple? All right. Of course, that should be 20. So we can simply change that one to something over 20. Of course, why? We want the denominators to be equivalent. So to change 10 to 20, you simply multiply it by 2. You have to do the same to the numerator. And that should give you 7/20 minus 2/20, which is 5/20. And of course, you know, if you simplify 5/20, you will get a quarter. And of course, you know, a quarter is 0.25. So you choose the method that you feel convenient with, but I like the one on the left side if you ask me. It's now time for you to pause the video and practice what you've learned. So pause the video and answer question 5 in 3 minutes. Assuming you've paused the video and you've answered question 5, here are the answers. So for question 5, you were asked, Ron and Whitney are working out the calculation 3/4 minus 0.2. Here, Ron says, I am going to start by converting 3/4 to a decimal. Here, Whitney says, I'm going to convert 0.2 to a fraction. And here is Ron's method. So Ron converted 3/4 to 0.75 and simply did his subtraction. And here is what Whitney did. So Whitney converted 0.2 to 1/5 and did her calculation like this. So the question is, what mistake has Ron made? Okay. What mistake has Ron made? So Ron, he has subtracted 200s, not 2 tenths. Okay. So if we want to convert Whitney's answer to a decimal, okay, because Whitney is correct, so we need to make this 100 by multiplying by 5, 100 by 5 as well. So this is now 55 hundredth. Okay, and you see it's now easy to convert it to a decimal because you were asked to write your answer as a decimal. That should be 0.55. The mistake Ron has made is that for this one, remember when you do subtraction or addition, you have to make sure the decimal line up. Why does the decimal have to line up? Because by making sure the decimal line up, the place values automatically line up as well. So this should be 0.2. So this is what Ron should have done. Ron simply subtracted this. So this is the 10th, but he subtracted it from the 100th place. So your answer should be 0.55. So if Ron had done it properly, that should have been his answer. Pause the video and answer question 6 in 3 minutes. Assuming you've paused the video and you've answered question 6, here are the answers. Let's discuss them. So for question 6, you were asked to work out the calculations, okay? Give your answers as decimals, all right? So here, we can use simple knowledge of equivalence to do this. We know that although looking at this calculation at first, you may be taken aback, you may be surprised, how do I do this? But we know that a half is 0.5. So this is as simple as 0.6 minus 0.5. So I'll just make comments on them and you will see how the answers play out. This will be 0.7. We know that 1/5 is 0.2. So 0.7 minus 0.2. Okay? And that's why it's 0.5. Here, this will be 0.65 minus 0.25. We know that a quarter is 0.25. And of course, you can see why 0.6. This will be 0.9 because 9/10 is 0.9. 0.9 minus 0.25. And of course, you see why it should be 0.65. And of course, we did by converting the fractions to a decimal before we did our calculations because we understand the equivalence of those fractions. Okay, let's look at something else. If we have this representation, how do we write this calculation? What do we think is going on here to find this missing part? Well, if you think about it, which calculation can we pick? Now, first, we need to know what each interval is worth. So we know from 0 to 1, we know that the difference is 1. And then we have 1, 2, 3, 4. Now, if we have to divide 1 by 4, it means each of these is a quarter. All right? So it means each of these is a quarter. So a quarter, 2 quarters, 3 quarters, and then 1, 4 quarters. So they're asking us what this representation actually means, which calculation here represents it. So first we need to know that this represents 2.5 because this is 2 and a quarter and then a half. And then if we subtract 1 and a quarter, we'll get this. So this we need to find all the calculations that represents 2.5 minus 1 and a quarter. This one straight away represents it because this is 2.5, which is 2.5. Okay, and then 1 and a quarter is the same thing as 5 over 4, right? 1 and a quarter is 5 over 4. Remember how we change mixed number to improper fraction? So you should go and review that if you don't remember. This one is definitely 2.5 because 10 over 20, we can simplify it to a half. Okay, we can divide the numerator by 10 and the denominator by 10. That should give us 2.5. And then a quarter is 0.25. So this is the same, it represents the same calculation. But this one, not quite, because we have 2.5. This is 2.2. So the next one should be 2.5 because we know 5 over 2, if we change this top-heavy fraction or improper fraction to a mixed number, is going to be 2.5. And we know that this, we've already seen that 1.25 is 1.25. So these calculations represent the diagram there. What about this one? Which of these fractions are equivalent to terminating decimals? So this is our final example. But did you know what terminating decimals are? Okay, in maths, there is something called recurring decimals. So when you have the decimal, when if you were to use your calculator to work it out, or even your bus stop method, you will notice that the decimals carry on. Some numbers keep repeating. So we call those recurring decimals. So terminating decimals are decimals that when you just do work out the decimal, it stops somewhere. You cannot carry on. Okay. So very quickly, we know all the equivalent fractions there. We know that is 3/10. We know that is, which is 0.3. So it terminates. We know that is 1/5, which is 0.2. So we know it terminates. And we know this is a quarter, which is 0.25. So it terminates. So definitely the only one that is the terminating decimals is the 1/3. Okay. And you can see it there. All right, it's now time for you to pause the video and answer the other questions that follow. So pause the video and answer questions 7 and 8 in 2 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So here is a representation of a calculation. They're asking you which of these is not the calculation shown or is not shown in the calculation. Is this one. Why? Because if you look, we have 1, 2, 3, 4. So it's almost like the one we saw before. So this represents 2.25. 2.25 minus 1/2. Okay, so that is the only one that does not represent it. Next, you're asked, the same digit is missing from each box. So let's move this out of the way. The same digit is represented in each box. Which digits would give a terminating answer? Okay, which digits will give a terminating answer? And these are the digits. Okay, 0.2 plus 0.5 will give you 0.7. Okay. And that brings us to the end of our lesson. So far, we have learned how to make really good use of our knowledge of equivalence to answer some very difficult, what may seem to be difficult maths questions. But when you use the right tools, you use your knowledge of equivalence, you can answer these questions relatively easily. So well done for sticking around and for taking your learning seriously. Until next time, take really good care of yourself and your friends and family, and bye-bye.